Good day, students. In this clip, you're going to be going over how to use trigonometric tables to evaluate trig expressions. So, right on the title of this lesson, it's applying, um, making use, let's put this right, making use of trig tables. Okay, so I have right down below me a trig table. You should have a copy, and we're going to be making use of this trig table to evaluate trig expressions. So let's write on the instructions for the notes for today. Find the degree and gradient measures of the following expressions. Okay, all right, so I'm going to be making use of this table down here to evaluate the expressions that we are given. Let me shift it down a little bit. So number one, first one, we're going to work on finding the arc cosine cosine of -1. Arc cosine of -1. Okay? So to do this, we just have to know that arc cosine of -1 is equal to cosine to the -1 of -1. Alright? Arc cosine and cosine to the -1 mean exactly the same thing. So how do we do this? All you just do is you're just going to go from your cosine to your number to the angle. Okay, so starting, we're going to look for cosine. There goes your cosine right there. There you have cosine. They're right in your table now. So I'm going to trace from there to -1. So from cosine, I'm going to trace to -1. You see -1 right there. And then I'm going to trace up, and that's one of my answers. All right? Is there another -1? No, that's basically that. All right, so so we're going to go from cosine to the value that we need. This is a -1 that's in the parentheses, and then this is my answer right here. So my answer is going to be pi in radians, or remember pi is the same thing as 180 degrees. All right. All right. Now let's take a look at another example. Let me get rid of these objects. In example 2, we're going to be looking for the inverse sine of √3/2. So everybody write this down for number 2. What is the inverse sine to the -1 of √3/2? Now this is the same thing as the arc sine of √3/2. So remember, arc sine and inverse sine are the same thing, okay? So it's going to be the same procedure as we did before. We're going to identify sine. We're looking for the arc sine. So we're going to start from sine. Don't write on your sheet now, okay? So from arc sine, we're going to look for √3/2. So that goes the first possible answer, and then we just go straight up to my answer. Is there any other √3/2? Yes, this goes another one. There goes my answer. Any other one? No. So we're going to have two output values. This is the first one, and this is the second one right there. Okay. I kind of wrote over my answer, so I'm going to erase it and rewrite it. So this is your second answer right here. All right. So my answers are for the arc cosine of √3/2 or inverse sine of √3/2 is going to be pi over 3, or 60 degrees, and 2 pi over 3, or 120 degrees. Okay, so we have two answers for this one. All right, number 3, let's take a look at inverse tangent. Inverse tangent, what is the inverse tangent of √3/3? √3/3. So for this one, we're going to be using exactly the same procedure as we did before. And then we're going to attempt to find what the inverse tangent is. All right, let me just get rid of these objects real quick. Put them out. All right, so Identify tan, inverse tangent. Inverse tangent is right here. Oh, it's not right here. Inverse tangent, tangent is right here, so we're going to trace to root 3 over 3. So you see the first one is right here. So that's going to be your first answer. And then the next one, you're going to trace to that, and that's going to be your next answer. So we're going to have two answers for this one, okay? So the first answer is going to be that, because if you trace it, you hit root 3 over 3 here. And then the next one is going to be that. When you trace it, you hit 7 pi over 6 there. So your final answers are going to be tan to negative 1 over 3 over 3 is the same thing as arctan of root 3 over 3, which equals pi over 6 or 30 degrees and 7 pi over 6 or 210 degrees. Okay? Alright, let's go ahead and try one more example, then we're going to go ahead and take a look at, get started with the classwork for today. Okay? Just clear that out. Okay, here's a little bit slow. Number 4. In number 4, we're going to attempt to find the inverse secant of root 2. Okay, secant to negative 1 of root 2. Well, let's make it negative root 2. Okay, inverse secant of negative root 2. So remember that inverse secant is the same thing as arcsecant. The arcsecant of negative root 2. Alright, so that's going to become, let's see what the values are. So if we start from secant right here and we trace, we look for negative root 2. It's going to take us to here. That's one possible answer, so you trace it up. And then the next one is right here. That's another possible answer. You trace it up. Those are our two output values. Those are our two results. So this gives me the first answer, which is this. And then this negative root 2 gives me the second answer, which is that right there. Okay? So let's write down what the values are. So our answers are 3 pi over 4 or 135 degrees and 5 pi over 5 pi over 4 or 225 degrees. Okay? So that's it for the first part of the notes. Thanks for paying attention. Now we're going to go ahead and start with the classwork. Alright, so sorry about that. Now the second part of the notes, still continuation. Now in this part we're going to attempt to find the exact and approximate values of the following. Approximate values of the following. Okay? Alright, the following. Alright, let's start with number 6. Number 6, we're going to have sine 30 degrees. Alright, so for sine 30 degrees, we're going to look for sine, trace it to 30, and then we're going to see where they meet. So this is sine right here. Sine is basically right here, sine, and that's 30 degrees. So where do they meet? Let me redraw my 30 degrees. There goes 30 degrees. And then when you trace them down, where do they meet? Sine goes here, and 30 degrees goes straight down, so there goes your answer. Alright? So sine 30 degrees is basically 1/2 in the decimal form. 1/2 is equal to 0.5. Alright? So there you have it. I want you to give me in fractional form and also in the decimal form. Now let's take a look at number 7. Number 7, we're going to try cosine pi over 6. But let me delete these objects. Look down my table a little bit to make more space. So for number 7, we're going to try let's do cosine of negative pi over 6. Okay? So where is negative pi over 6? The negative values of the angles are beneath the table. If you notice, you have the negative pi over 6 right here. So for cosine, we're going to, this is cosine right here. Cosine. And then this is negative pi over 6. So where do they meet? Wherever they meet, that's your answer, okay? So cosine goes to the left, to there, and then negative pi over 6 goes up. Or if you have energy, you can use this cosine, and then this is still where they intersect, right? So basically, this is your final answer right here, root 3 over 2, okay? So your answer is going to be exactly root 3 over 2. And then you also need an approximate value, so you just fire up your calculators. We're going to input root 3 over 2 in the calculator, so be sure you do this correctly. So to do that, we're going to go square root of 3. Please close this parenthesis first, okay? Divided by 2, and it's 0.8660. So approximate value is 0.8660. Okay, so 0.8660. All right, number 8. Let's try secant of 5 pi over 3. What is the exact and approximate value of secant 5 pi over 3? All right, let me clear out this object real quick, and then we're going to find out what, got too much done. Select these, take it out. Alright, so secant 5 pi over 3, for that one, we're going to have, let's look for where secant is first. So secant is right here. Secant and secant. 5 pi over 3, where are you? Oh, gosh. Okay, there you go. So where do they meet? Secant comes straight there, and then 5 pi over 3 comes straight down, and then they're going to intersect right here. Oh, wrong object. They're going to intersect right here, so basically there goes your answer. Your answer is 2. So for this one, your answer is simply 2. Okay? Alright, let's try number 9, and then we're going to go ahead and start with the first part of the classwork for today. So number 9, we're going to try and find cotangent 2 pi over 3. Okay, so what is cotangent 2 pi over 3? Let's see, where's cotangent? There goes cotangent right there. Let me erase the other ones so you don't get confused. Take this out, take that out. Just put these ones out of the way. So cotangent 2 pi over 3. Cotangent is right there. This is cotangent. And then that's also cotangent, and we're looking for 2 pi over 3, which is right there. So basically, cotangent goes all the way there, and then 2 pi over 3 goes down, and there goes your intersection. That's where they intersect with 3 over 3. So your answer is going to be where they intersect, which is right here. So cotangent 2 pi over 3 is equal to root 3 over 3, actually negative root 3 over 3. And then if you want to find the approximate value, you just go put in negative root 3. Close it first, please. Divided by 3. And your answer is negative 0.5774. Okay? So negative 0.5774 will be your answer. Negative 0.5774. Alright? So that's that. Welcome back, students. Now this week we're going to be doing a review on right triangle trigonometry. So let's write down the title of the notes. Review on or of review of right triangle trigonometry. Okay, review of right triangle trigonometry. Okay, trig. All right, so let's take a look at the first example we're going to do, but we'll write down the instructions first. So this is instructions. Find the sine and cosine of the angle with the given trig function. And then verify your answers with a calculator. Verify your answers, your results with a calculator. Okay? Alright, so let's take a look at example one. What if we had tan x equals 4/7? Alright, so from SOHCAHTOA, we know that tan is opposite over adjacent, right? So we know that this is the opposite and this is the adjacent. So what we're going to do is we're going to create a right triangle, and then we're going to label it using the information that we just got. Okay, so let's just create a right triangle right here. This is x. Let's just call this x. If this is x, that makes this the opposite, which is 4. And then this is the adjacent, which is 7. And this is the hypotenuse right here. Okay? So we know that AC squared is equal to a squared plus b squared. We can also say that h squared, which is the hypotenuse, is equal to o squared plus h squared. Plus a squared. Because we know that this can be a and this can be b. Alright? So we plug in that information. We know that h squared, the hypotenuse square, is equal to 4 squared, because 4 is the opposite and 7 is the adjacent, 7 squared. Alright, so h squared is equal to 16 plus 49. When we add it up, we're going to have h squared is equal to 65. And the hypotenuse is basically the square root of both sides, the square root of 65. Okay? So can that be reduced any further? Let's check. We can take out 5, and then we're left with 13. And neither of these can be broken any further. So our hypotenuse is just root 65. Okay? So we have O as 4, A as 7, and H as 65. Now we can find sine and cosine. So sine x is opposite of a hypotenuse. Okay? From SOHC, sine opposite of a hypotenuse. So it's going to be, the opposite is 4, the hypotenuse is root 65. Now we're going to rationalize the denominator because you're going to have a square root as a denominator, so root 65 top and bottom. And then the final answer is going to be 4 root 65 over 65. We also need an approximate result so that we can compare our answers with our calculator results when we're done. So if we put this in our calculator, what are we going to get for root 65 divided by 65? Answer is 4.961. 4.961. Okay, 0.4961. So let's write that down. 0.4961. Alright, and then for cosine x, cosine from ka, adjacent of a hypotenuse, our adjacent is 7 and the hypotenuse is root 65. But we can have a square root as a denominator, so we have to rationalize the denominator, root 65 top and bottom. So our answer is going to be 7 root 65 over 65, which is approximately in a inexact form, is decimal form. We're going to have 7 root 65 divided divided by 65, and it's going to give us 0.8682. 0.8682. Okay? Alright, so 0.8682. Now these are answers in using the triangle. Now let's verify our results using the calculator. So before we use the calculator, we need to know what x is first. So since tan x, so calculator, let's just put calculator here, calculator, and underline that so we know what we're doing. Alright, so since tan x is equal to 4/7, then in order to get x by itself, we take the inverse tan of both sides. Okay, we take the inverse tan of both sides. So we're going to take the inverse tan of tan x on the left, of tan x, and the inverse tan of 4/7. All right. So basically, that tells us that x, because this tan and the inverse tan are opposites on the left, so these cancel out. So x is basically the inverse tangent of 4/7. Okay? So to find sine x is simply the sine of the opposite of the tangent of 4/7. So of the inverse tangent of 4/7. Why did I do that? Because x is the inverse tangent of 4/7. So I just took this x out and I replaced it with the inverse tangent of 4/7. So this is what we're going to place into our calculators. And I'm going to put the answers in. Alright, so that's what we're going to use. Sine of the inverse tangent of 4/7. So we're going to go sine of the inverse tan of 4 divided by 7. And our answer is 0.4961. So, so we have 0.4961, which is exactly what we have out there. So our answer is correct. This one checks out. All right, let's do the next one. So for cosine, what we just need to do, cosine x, since tan x is 4/7, we're going to take the opposite of tan, which is the inverse tan. So cosine of the inverse tangent, cosine of the inverse tangent of 4/7, because the inverse tangent of 4/7 is x. So that's what we'll replace for this, okay? And then that's what we'll put in our calculators. We're going to go cosine of the inverse tangent of 4/7. And our answer is 0.8682, which is excellent. So our answer here is 0.8682, which is excellent. So that's basically that. Okay? Alright, so let's box our calculator results. And now we're going to go ahead and get started with the second part of the classwork for today.